Okay, now we're going to be talking about another important part of polynomials. So another important part of polynomials is the end behavior. Okay, that's what basically the second half of this lesson is all about, the end behavior. Let's actually talk about what end behavior is. The end behavior tells us what is happening at the ends of the graph. Okay? So when you actually have a drawn out graph, finding the end behavior is pretty simple. So let's say, for example, draw this in your notebook. We have a coordinate plane, right? And let's say we have a function that looks like this, right? You should know by now that this is a third degree function. So in like normal words, right, on the left side it's going down, right here, and on the right side it's going up, right? So the end behavior in a way is, you could say, is down up. Now we want to actually use some like proper mathematical notation, so let's annotate our graph. So if we were to keep going forever this way, right, we're going to hit infinity, right? So this is x goes to infinity. On the other side, this is the same thing as x goes to negative infinity, right? Because it's the negative part. Similarly with the y's, if we go up, that means y goes to positive infinity. But remember, sometimes instead of y, we write f of x, right? F of x and y are the same thing. And on the other side here, we can say that y goes to negative infinity, right? And again, sometimes we write y as f of x, right? So let's first write the end behavior like in normal terms. So on the right side, so we can say on the right, it's going up, right? And then so that's the right side, that's this side right here. And now on the left side, it's going down, right? So I'm just gonna write that. On the left, it's going down. Now let's actually write this now with like the mathematical notation. So on the right means as x, I'll just write as x goes to infinity. So as x continues on to the right forever, it's going to keep going upwards, right? It's going to go towards positive infinity. So we can write f of x goes to infinity, right? This just means as x goes to the right, the function's going up all the way to infinity. Now on the left-hand side, right, left-hand side means we're going to negative infinity. So as x goes to negative infinity, f of x, well, it's going downwards, so it's going to go towards negative infinity, right? So your function, you're always, like, this part is always going to stay the same. What is going to change is, hey, is it going up or is it down, right? Like, that's the part that's going to change. So on a graph, that's really easy to see. Now, sometimes they're not going to show you a graph, and you could graph it, but there's actually a trick to figure out what the end behavior is, and that's by using the degree. Okay, so when we have the equation, we can use the degree and leading coefficient, so I'm just going to write LC, to find the end behavior. Okay, so we're actually going to make a table, and I'm going to explain to you what this table does. So in your notebooks, like this table, I want you guys to make it pretty large. You're gonna make a large like rectangle, and then you're gonna split it into 4 parts like this, okay? So there's 2 things that we're looking at. We're looking at the degree and we're looking at the leading coefficient. With the leading coefficient, we care if it's positive or negative. So at the top here, I'm going to say leading coefficient is positive. Here, the leading coefficient is negative. And then for the degree, we care if the degree is even or odd. So degree is even and degree is odd. Okay? So we're gonna go like box by box and we're gonna write some notes. So let's first talk about when the leading coefficient is positive and the degree is even. An example of this could be like 2x squared, right? Because the leading coefficient is a positive number, it's 2, and the degree, which is also 2, is even. Now, if you think about it, the shape of this is going to look like a U, right? Because it's x squared. And so if you think about what's happening at the end, on the right side it's going up and on the left side it's going up. So I'm going to write that in words. Right is up and left is up. Okay? So now let's write it in the mathematical way. So remember, this way is going towards positive infinity, this way is to negative infinity, infinity, and negative infinity, right? So as x goes to infinity, right, f of x is going to go up. So f of x goes to infinity as well, right? That's representing this side right here. As x goes on to the right forever, it's going upwards towards infinity. Now the left side is also up, but now we're going to negative infinity, the x's. So as x goes to negative infinity, f of x goes to infinity, right? This part means you're going to the left, and this part means you're going up. This part means you're going to the right, and this means you're going up. So that's why you get the up and the up, okay? Now, let's talk about if the degree is even and the leading coefficient is negative. For example, that could be negative 2x squared, right? So all that's going to change with the graph, it's now going to be upside down, right? So instead of it being up, up, it's going to be down, down, right? So again, I'm going to write it in words. Right is down, left is down. So to talk about the right, we're going to say as x goes to infinity, right? That means the right. F of x goes to negative infinity. That's the down part, right? This right is here, and the down is here. Now similarly, now we're talking about the left. So as x goes to negative infinity, f of x, well, it's going down, goes to negative infinity. Again, the left is this part right here. The down is this part right here. Okay? So that's both if the degree is even. Okay, let's now talk about if the leading coefficient is positive and the degree is odd. For example, if we have 3x to the third, okay? That's going to look something like this, right? So if you notice, the right is up and the left is down. So again, to talk about the right, we say as x goes to infinity. And then to represent up, we do f of x goes to positive infinity, right? The up, this part means up, and this part means right. Okay, now we're talking about the left. So we have as x goes to negative infinity, f of x, well, it's going down, goes to negative infinity. Okay? So this part means down. This part means left. Okay? And then last box, if the degree is odd and the leading coefficient is negative. For example, if we have negative 3x to the third, all that's going to do, it's actually going to just flip the graph, right? So now the right is down and the left is up, right? Hopefully at this point you can fill in the mathematical notation, right? If you can't do this by now, you should ask for help. So the right means as x goes to infinity, down means f of x goes to negative infinity, left means as x goes to negative infinity, up means f of x goes to positive infinity, okay? So this is like your chart, okay? So let's say, for example, they give you this function. Let's say f of x equals negative 3x to the 7th plus 2x to the 3rd minus 7, okay? First thing you want to do, identify your leading coefficient. That's negative 3. Is it positive or negative? It's negative. What's your degree? The degree is 7. Is that even or odd? It's odd. So we're looking at the odd and we're looking at the negative. So negative and odd is right here, right? So our end behavior would be this. As x goes to infinity, f of x goes to negative infinity. As x goes to negative infinity, f of x goes to infinity. You just copy down what we wrote down in the chart, okay? It looks way more complicated than it actually is. If you have questions, ask for help. Otherwise, try the practice.